Hello guys, this is part 2 of my video on reflection. Please ensure that you watch part 1 before you watch part 2. Now, we're going to start this video by looking at a reflection in the line y equal x. So, the first thing I need is my mirror line. The line y equal x is my mirror line. Now, what does the y equal x mean? It means that whatever coordinate x is, the y coordinate is the same. So to draw that line, I simply could choose the point 2 for x, which means that y will also be 2. And you could probably choose -2, which means that y would also be -2 if x is -2. So whatever the x coordinate is, the y coordinate is the same. And once you have two coordinates, you can draw that line. So y equal x. Alright, so it's a straight line that runs directly through the point 0, 0. If you have that, then we're good to go. Now, here's an activity that you could do in the meantime to discover what is going to happen with the image or what the image is going to be. You could draw this on a graph paper. You could put your ruler along the line y equal x. You could bend the paper, and at the back of the paper you print out the points. You open back the graph paper, and then you print out the image. That is one way of doing it. Now let us see what happens with the image. Bear in mind that the coordinates of my object are at the top left here. So A is 1, 9, B is 5, 7, and C is equal to 1, 5. So let us see what happens with this reflection. So I'm going to be using the GeoGebra software again, and I'm reflecting the line y equal x. Alright, this is interesting. Look at coordinate A. We all agree that coordinate A was 1, 9. Look at A prime. A prime is 9, 1. Coordinate B is 5, 7, but B prime is 7, 5. The coordinate of C is 1, 5, but C prime is 5, 1. Now we can actually directly see what is happening here. Alright? What we notice is that the x and the y coordinates interchange. In other words, the x coordinate becomes a y coordinate and the y coordinate becomes the x coordinate. So that is what happens when we reflect in the line y equal x. The x and y coordinates change to produce the image. So as we were saying that A is 1, 9 and A prime is 9, 1. Alright? Bear in mind that the x coordinate for A was 1. But now that 1 is the y coordinate for A prime. And the y coordinate for A was 9. And for A prime, the x coordinate is 9. So they switch coordinates. That is what happens when you reflect in the line y equal x. We're now going to look at the reflection in the line y equal -x. What does it really mean when we say y is equal to -x? Alright, let me choose a simple coordinate for x. Let us say that x is equal to 2. If y is equal to -x, it means that y is going to be equal to -2. So y is a negative of whatever x is. So that is one coordinate, 2, -2. What if x is -2? Y would have to be +2 because y is a negative of whatever x is. Once you have those 2 points, you can simply draw the line. So I'm going to have y equal -x. That would be my line. Good. Now let us see what happens when we reflect this object here, and of course the coordinates of this object is A 1, 6, B 5, 4, and C 1, 2, and the line y equal -x. Let us see what happens. Alright, so there is my image, A prime, B prime, C prime. Now look at the coordinates of the image. Bear in mind that from the object A was 1, 6. Look at the image, we have -6, 1. Look at B. B was 5, 4, but B prime is -4, 5. Look at C. C was 1, 2, and C prime is -2, 1. What do we observe happening here? We notice that the coordinates have switched. So the coordinates for A was 1, 6. It switched because now we're seeing 6, 1. But it's not just 6, 1. It's -6, -1. So the coordinates switch and they become negative of what they were. So for instance, C, which is at 1, 2, to get C prime, I would switch that and say 2, 1 and make them negative. So it's -2, -1. And if you see it down here, C prime is -2, -1. Look at B. B is 5, 4. So when it's reflected in the line y equal -x, the coordinates switch. So it becomes -4, -5. So they switch and they become the negative of what they were. Now we can manually carry out a reflection in certain axes or lines using what we call a 2 by 2 matrix. Now, if I'm going to use a 2 by 2 matrix, then I'm going to have to start with, of course, the identity matrix. And why? Because whenever I multiply anything by the identity matrix, it will remain the same. The identity matrix is just like the multiplicative identity, which is 1. So if I multiply 5 by 1, I'm also going to get back 5. A similar concept happens with the identity matrix, and that is normally written as I. So I equal 1, 0, 0, 1. And practically any coordinate we multiply by this will remain the same, right? So if I were to go 1, 0, 0, 1, multiply by xy as a general coordinate, this is what will happen. Remember, when we multiply a matrix, we multiply rows by column. So in this case, I'm going to have 1 times x plus 0 times y. Then I'm going to have 0 times x plus 1 multiplied by y. Alright, now when I break this down, it simply comes down to 1 times x plus 0 times y. That is going to give me x. And likewise down here, I'm going to end up back with y. So this is my identity matrix. Let us start with a reflection in the y-axis. From the previous video, I would have established that whenever you reflect in the y-axis, the y value remains the same, but the x value becomes negative. What do I mean by that? If I have A to be, let us say, xy, when I reflect this in the y-axis, the y value will remain, but the x value becomes negative. So A prime would be negative x, the y value remains, right? So that is A and that is A prime. Now, what we want to do is to determine the 2 by 2 matrix that would represent a reflection in the y-axis. We also call it the line x equals 0. Now, we said that the y value remains the same, but the x value becomes negative. Now here, what I did is that I went back to look at my identity matrix, which is 1, 0, 0, 1, and I want to know which value inside of this matrix impacts the x value. In other words, which value should I make negative so that the x value becomes negative but the y values remain the same. So what I have done is that I would have put the row 1 in blue, which is 1, 0. So notice when I multiply in my matrix over here, I have 1 times x plus 0 times y. What that really means is that the 1 will multiply the x, so the x value will come back in its original position. 0 times y means that the 0 will go out there, alright? So it will not come in the x position. Likewise, in red, I have row 2. So the 0 will multiply my x value and the 1 will multiply my y value, which means that the 1 in row 2 is responsible for bringing back the y value, and the 1 in row 1 is responsible for bringing back the x value. Good. Now, as we say, the y value will remain, so I'm not going to trouble row 2 any at all. But the x value becomes negative, which means I'm going to have to modify row 1. So for me to get the 2 by 2 matrix or reflection in the y-axis or the line x equals 0, I would have to change row 1 to negative. So in this case, I am going to end up with, so let me call it a matrix M. So M would be equal to negative 1, 0, 0, 1. Now, of course, we know that 0 can't be negative. 0 is neutral. Right? We have come up with a 2 by 2 matrix for reflection in the y-axis or the line x equals 0. Let us test this. Let us say we have a point. I'm going to call that point A, 3, 4. We already can guess what the image is going to be, A prime. We say if we reflect in the y-axis, the y value remains the same. So I can put about the 4, but the x value is going to become negative. So I'm expecting to get negative 3, 4. Let us see if this matrix actually works. So we are saying that A prime would be equal to this matrix. I just call it M. Would be equal to M multiplied by A, the original matrix. So bear in mind that when I'm finished, I should actually get negative 3, 4. So I'm saying this is equal to negative 1, 0, 0, 1 multiplied by 3, 4. Okay. Bear in mind the concept for multiplying matrix. We say we multiply rows by column. So here we go. We're going to have negative 1 times 3 plus 0 times 4. Then we're going to have row 2, which is 0 times 3 plus 1 times 4. When we break this down, I'm going to get negative 3 and I'm going to get 4. So it does work, because bear in mind we had guessed that this would have been the answer, or we knew that this would have been the answer. So we can say therefore a prime is negative 3, 4. Bear in mind we have to write this horizontally because it is a coordinate. So it does work. Now you can take on the challenge and carry out a similar procedure to determine what the 2 by 2 matrix is for a reflection in the x-axis or in the line y equals 0. If you did the investigation, then you should have come up with your 2 by 2 matrix for reflection in the x-axis. We also call it the line y equals 0. Now bear in mind what we said happens when you reflect in the x-axis. So if I have the coordinate a, which is xy, when this is reflected in the x-axis, we say that x will remain the same, but the y value becomes negative, negative y. Now the identity matrix I, as we know it, is equal to 1, 0, 0, 1. So to come up with a 2 by 2 matrix for this transformation, I'm always going to start with the identity matrix. Now from my previous section, we spoke about the fact that at the top here, where I have 1, 0 there, that is what will produce my x value. Alright, so I want my x value to remain the same. I'm not going to trouble that, so I'm going to leave it at 1, 0. But I want my y value to become negative. So I'm looking at row 2 here, which is what will impact my y value. So I need my y value to be negative. I need my x value to remain the same. So right away, we know that this matrix M for reflection in the x-axis will be 1, 0. 1, 0 there means that my x value will not change. My y value, on the other hand, I need that to change. So I'm going to have 0, negative 1. And this is a 2 by 2 matrix for a reflection in the line y equals 0. We know it better as the x-axis. For a reflection in the line y equals x, we know that if the original coordinate, like what I have here on the left, is a xy, then a prime is going to be yx. Now let us look at the identity matrix and its impact on xy. Now what I want is for this to switch. So I want y to be at the top and x to be at the bottom. So let us see what will happen here. Over this side we have 1 times x plus 0 times y. I want y up there. I don't want y to be cancelled out. I want x to be cancelled out. So what I can simply do here is to change this one here to 0. I would change this 0 to 1. Likewise in the denominator, I need x down there. So what it means is that I would have to change this 0 to 1 and this 1 to 0. So ultimately, my 2 by 2 matrix for reflection in the line y equal x would just be, let me call it M equal 0, 1, 1, 0. Right? So notice that just like how the coordinates would switch, so does the matrix. So where you normally have 1 in the identity matrix, you have 0. Where you normally have 0, you now have 1. Here's an example of a question. A triangle has coordinates P, 2, 1, Q, negative 3, negative 4, and R, 2, 4. Determine the coordinates of the image under the reflection in the line y equal x. So the first thing I need is a 2 by 2 matrix for a reflection in the line y equal x. And as we proved before, that 2 by 2 matrix is 0, 1, 1, 0. Now I'm going to lay out the coordinates of my object here, which is 2, 1, negative 3, negative 4, and I'm putting them in vector format, and 2, 4, so we can carry out the operation. So I have P, Q, R. Now, remember that whenever you multiply two matrices, we multiply row by column. So we're going to have row 1 times column 1, then row 1 times column 2, and so on. So let me lay this out. So this is going to become, so we're going to have 0 times 2 plus 1 times 1. Then we're going to have row 1 again times column 2, which is 0 times negative 3 plus 1 times negative 4. Then I'm going to move to row 1 again, but this time I'm going to multiply row 1 by column 3. So I'm going to have 0 times 2 plus 1 times 4. We finished with row 1. We're going to move to row 2. So row 2 again is going to multiply column 1. So this is going to give me 1 times 2 plus 0 times 1. Then I'm going to have 1 times negative 3 plus 0 times negative 4. Then I'm going to have 1 times 2 plus 0 times 4. Now, when I break down all this, all that I'm going to end up with is 1, negative 4, 4, 2, negative 3, 2. And bear in mind that we have P prime, Q prime, and R prime. So we can write down the coordinates of a triangle. So the coordinates of P prime, Q prime, R prime, which is my image, will be P prime, which will be 1, 2, Q prime, which will be negative 4, negative 3, and R prime, which will be 4, 2.